All right, let's jump into one of the most famous brain teasers in all of history. Seriously. It's this incredible story about how a simple stroll through an old city ended up creating a whole new branch of math, and, believe it or not, made our modern world possible. So picture this. You're in this beautiful 18th century city called Königsberg. It's got a river running through it, two big islands, and everything is connected by 7 bridges. And here's the challenge everyone's talking about. Can you take a walk that crosses every single one of those 7 bridges, but you can only cross each bridge one time? Go ahead, think about it for a second. It sounds simple enough, right?
Well, for years and years, the people of Königsberg tried. They tried every route imaginable. They'd start on the north bank, then the south, then an island, but it never worked. They'd always end up either missing a bridge or having to recross one they'd already been on. It was maddening. It felt impossible. But, proving something is truly impossible, that's a whole different ballgame.
So to really crack this, we have to go back in time and get a feel for the city itself. Okay, so the city itself was set up on both sides of the Prego River, with these 2 big islands sitting right in the middle. And these 7 bridges were like the city's arteries, connecting everything together. And this little puzzle, find a path, cross each bridge just once, it became a local obsession.
And this is where our hero steps onto the scene, a brilliant mathematician named Leonhard Euler. Honestly, one of the greatest minds ever. He hears about this ridiculously frustrating puzzle and he gets hooked. But he wasn't just trying to find the path. No, he wanted to figure out the deep underlying reason why a path might or might not exist at all.
And what Euler did next was, well, it was completely revolutionary. He basically realized that everyone was looking at the problem from the wrong angle.
His big aha moment was this. The exact layout of the city, how long the bridges are, which streets you take, none of that actually matters. He stripped away all the unnecessary details to get to the core of the problem.
And this is the giant leap. He said, look, it's not about the bridges themselves, it's about the land masses that the bridges connect. The bridges are just the paths. The important things are the destinations. It's not about the lines, you see, it's about the dots they connect.
So with that idea, he redrew the entire map. He turned each of the 4 land masses into a simple dot, which he called a vertex. And then he drew a line, an edge, for each of the 7 bridges connecting those dots. And just like that, the messy city map turned into this beautiful, clean, simple diagram. And by staring at this new, simplified diagram, Euler discovered something amazing. A super simple, elegant rule that unlocked the entire puzzle.
Here's his breakthrough, and it's so simple, it's brilliant. He said all you have to do is look at each dot, each landmass, and count how many lines or bridges are connected to it. If a dot has an even number of lines touching it, 2, 4, 6, he called it an even vertex. If it had an odd number, 1, 3, 5, he called it an odd vertex.
So why on earth does this matter? Well, think about an odd vertex, one with, say, 3 bridges. You can walk in on bridge 1, and you can walk out on bridge 2, no problem. But then, if you ever come back to that landmass using bridge 3, you're trapped. You've used all the bridges, there's no way out. Odd vertices are like potential dead ends. But even vertices, they're totally different. They're easy. For every bridge you use to go in, there's always an unused partner bridge waiting for you to go out. They're like perfect little pass-through points. You can go in and out of them all day long and you'll never get stuck. So, this simple idea about odd and even points led Euler to create 3 simple, rock-solid rules that can be used to solve any path problem like this anywhere. And here it is, the grand solution. It's all about counting the odd vertices. Rule 1. If your network has 0 odd vertices, you can absolutely do it. You can even start and end at the exact same spot. We call that an Euler circuit. Rule 2. If there are exactly 2 odd vertices, you can still do it. But you have to start at one of the odd ones and end at the other. That's an Euler path. But rule 3, the big one. If your network has more than 2 odd vertices, it's impossible. Period. You are guaranteed to get stuck.
Okay, so now that we have Euler's secret decoder ring, let's go back to that original puzzle.
When you look at that diagram of Königsberg and you count the number of landmasses with an odd number of bridges, what do you get? You get 4. And there you have it, 4 odd vertices. That puts it squarely in Euler's impossible category. He didn't just guess it was impossible, he proved it with pure, simple logic. The people of Königsberg could finally stop trying. It wasn't them, the puzzle was rigged from the very start. But the story doesn't end there, not even close. In fact,
This is where it gets really mind-blowing.
You see, Euler didn't just solve a local brain teaser. By turning that city map into a simple diagram of dots and lines, he basically, and completely accidentally, invented a whole new field of math called graph theory.
And graph theory, well, it pretty much runs our entire modern world. It's the secret sauce behind how FedEx and Amazon plan their delivery routes to be as fast and cheap as possible. It's how we design the internet, how airlines plan their flight paths, how your city plans its subway lines. It is everywhere.
Isn't that incredible? The solution to a frustrating little walking puzzle from the 1700s gave us the fundamental tools we use today for global logistics and network science. It's just a perfect example of how trying to solve one problem can end up changing the world in ways you never could have imagined.
And that kind of leaves us with a final thought. Euler solved the puzzle not by working harder, but by seeing it differently. He changed his perspective. So it makes you wonder, what seemingly impossible problem in your life or in the world could be solved if you just found a completely new way to look at it?